A pleasant day, STEM learners. This is Sir Peter, your statistics and probability teacher. For today's discussion, this is the first video lesson that will talk about the properties of the normal distribution. So at the end of this video lesson, you should be able to illustrate a normal random variable and its characteristics. So what is a normal distribution? A normal distribution is a distribution in which the frequency of the scores are greatest near the mean. So it means on the center, that is greatest, and progressively decreases towards the extreme. It is sometimes called the Gaussian distribution. That is in honor of one of the famous statistician, Carl Friedrich Gauss. And out of all the types of distribution, the normal distribution has the most important contribution or application in the real world. Sometimes it is also referred to a continuous probability distribution. So during your week number 1 and week 2, we talk about the discrete probability distribution in which our data are count data. But when our data are measured, so therefore they are continuous. So they could assume decimal and fractions as representations for the random variable. So the normal distribution is a perfect example of a continuous probability distribution. So this is a perfect example of a normal distribution. For example, the height of grade 11 male students. So normally, their average height ranges from 5'7" to 5'10", and they progressively decreases. So the lowest height of a grade 11 male student might be 5.1 and below, or for the higher extremes, we have 6.4 or 6'4" inches. Okay, that is height in feet. Look at the height of NBA players. As shown here, there are NBA players in which their height is 6'9", so that's 6 feet and 9 inches. So notice that NBA players are concentrated with taller heights. So this is not normally distributed. So the normal distribution is also referred as the normal curve, or sometimes it is also what we call the bell-shaped curve. So it's a theoretical and ideal distribution. So in real life, the empirical distribution never matched this model perfectly, but it is a perfect model for us to say that things are normally distributed. So these are the other kinds of distribution. So we have a negatively skewed or skewed to the left. Notice that there is less frequency on the left side of the distribution and high frequency on the right side. So the example a while ago, the height of the NBA players are skewed to the left. We also have positively skewed or skewed to the right. So notice that there is a high frequency on the left side of the distribution and a low frequency on the right side. So it is skewed to the right. Examples is the number of poor people in slum areas. So they are concentrated below, and there are only few rich people in slum areas. And we also have the random distribution. So anywhere on either the extremes or the lower extremes or higher extremes, or in the center, they could have different frequencies. So that is a random distribution. So examples of normal random variables are the heights of the seedlings. So when you spread mango seeds, you would notice that there are many seeds which have the same or average height, and few seeds will not grow, and few seeds will also grow tall. compared to the other seedlings. So the size of things produced by machines, the blood pressure of people. So many people are average in terms of blood pressure. So only few people experience high blood pressure and only few experience low blood pressure. The weight of newborn, the scores for tests taken by a large population. So what are the different properties of the normal distribution? First, the distribution curve is bell-shaped. As I've told you, the distribution curve is also what we refer as the normal curve. Second property, the curve is symmetrical about its mean. So notice that the curve's mean or mu is located on the center of the distribution. So it is symmetrical about its center. So there is symmetry about the mean. Next, third, the mean, the median, and the mode coincide at the center. So that is represented by our mean. Although the best measure that we use for any statistic is the mean. So if, as a statistician, if you use median and mode, it will still be located at the center when your population is normally distributed. So look at the skewness. For a perfectly symmetrical distribution, the mean, the median, and the mode coincides at the center. When there is a negative direction of the curve, meaning it is negatively skewed, the mode, the median, and the mean have different positions. Okay? So when there is a positive direction or a positively skewed, the mode is located on the left side and the mean is located still on the middle. So they do not coincide each other. Next, the curve is asymptotic to the baseline. So as you could see, if we are going to illustrate a normal curve, even if you extend this horizontal baseline, it may seem that the curve touches the baseline, but it will never touch the baseline because it is asymptotic to it. So that is why the normal distribution is also a continuous distribution because there is continuity on the baseline or the horizontal baseline. So it never ends. And it as it goes to the left and to the right, it will never touch that baseline. Next property. So there are two parameters for a normal distribution. First is the mean mu, which is located at the center and is divided into 6 standard deviation from the right and from the left, respectively. So in the middle, okay, represents the mean, and away from the mean is represented by the standard deviation or sigma. So that is the distance. So the location of the center is described by the mean mu, which is at the center. And the width of the curve describes how far is it from the mean. So the area under the normal curve is 100% or 1. So meaning from the center, there is 50% probability in here and also 50% of distribution on the right side. So this represents our 100% distribution or the probability of 1. So every probability under the normal curve is represented by an area, and that area here is 0.5 from the center going to the left and another 0.5 from the center going to the right. Along the horizontal line, the distance from one integral standard score to the next integral standard score is measured by the standard deviation. So in a standard normal curve, the value of mu is 0. Okay, and since we have one standard deviation each, so we will have 1, 2, 3. Because in a standard normal curve, it's represented by a standard deviation 1, -2, and negative 3. So in using empirical rule, when you draw the normal curve, you usually start with negative 3 going to 3 because this may not represent 100% of the distribution, but it is almost 100%. That is why when we draw, we put it from negative 3 to 3. So the empirical rule suggests that a negative 3 to 3 will have an area which is 99.7%. So it's almost near 100%. That's why this is the perfect model for the standard normal curve. So we are now done with lesson number 1. So for the next video lesson, we will talk about areas under the normal curve. Again, this is Sir Peter, your statistics and probability teacher.